Can you hear me? Don't know if you can hear me. Can you hear me? Perfect. I've got that irritating music in the background right now. So I don't know if I can hear you or not, but hey, let's work out what happens as we go along. All right, so as you can hear me, I'll just give you a quick rundown before we go live. I've got some weird things like this ticker at the bottom that will come up on the screen. A couple of sarcastic comments like, you can also do this in CDK, or you can also do this in SAM. We'll do a quick intro as to what today's episode is. We'll introduce you, and then we'll probably hand over to you, and then I'll either interject with comments and questions or let you run with it. I've got some list of questions as well, but otherwise it's pretty much freestyle. Okay. Let me know, give me a thumbs up when you're ready to go. Sweet. And it's at this point we go, is this thing on? Are we live? I think we are. I don't know. So let me get my other guest for a second. It's Bojan. You might need to unmute your mic. Is it working, mate?
I think it is. Let's see. Can you hear me?
We can hear you. Perfect. We are live.
Yes. Excellent. Okay. Great. Today I've been brought to you by your favorite airline. And if you can have a guess at which one it is, it's got a kangaroo on it. It's red and it likes to be late. I'm not going to name any names. Don't worry about that part.
Welcome to this week's episode of The Sounding Board. What is The Sounding Board? The Sounding Board is a community-driven program born out of my simple desire to lend a helping hand to the vast landscape of Amazon Web Services users out there that are learning and that are trying to get along, just like, you know, we all were at one point in life. Today, I've got a guest with me, a community expert, Bojan Zivic. I apologize if I've just butchered your name there, mate. He's an AWS ambassador, serverless AWS community builder for the second year running, just announced, and a principal consultant at Mental Group. What else do you do, Bojan?
Well, I do like to take flights that like to be late. I also like to sit at airports and jump on my phone Wi-Fi, and I am a big fan of all things serverless and CDK. But in reality, I've really been a big enjoyer of AWS, its evolution in the serverless landscape, where it was a titan in the 2016, 17, 18, 19, and then now the competition that it's caused. I'm a big fan of serverless technology and container technology to an extent. I say container to an extent because at the end of the day, everything is either a micro VM or a container. So it's good to be in the know for things as they grow. That's probably the best way to put it.
Exactly right. And look, that passion shows in everything you do in the community as well. You're a co-organizer of the Brisbane Serverless Meetup and Serverless Days. Even though you work out of Sydney, you travel to Brisbane, you travel to Melbourne, and you just get involved in the community.
Well, absolutely. The interesting story with Brisbane was there was an opportunity for us to kind of jump in and say, hey, this serverless event hasn't been running for the last 5 years. And we spoke to the organizer who used to run it, Peter, who's a lovely, lovely gentleman. And we basically said, let's take a shot. And we restarted it 2 years ago and grew up from a community of 17 to 30 to our last event. Actually, we had about 50 people. So we've definitely revived it, and it's definitely, become a staple, I'd say.
And the other thing that I like to poke fun at Bojan at occasionally is that he's also an avid CDK evangelist. Now, as you've probably noticed from a couple of my videos recently, I'm very much on the SAM side of the table. So you might see a few little pokes here and then that you can do this in CDK, you can do this in SAM. But today we're not here to talk about either
you know
of
what
those
it is,
things.
right? You know what it is? SAM and CDK get along really well. So whenever you want to chat on that, I've got some stuff to give you.
I think we've got an episode just about that coming up as well. I like that idea. Cool. But yes, today we're actually here to talk about serverless databases. When I mentioned this to Bojan, the look on his face told me it was a challenge to the point that he said, I have to do this. So I'm going to hand over the reins to Bojan to tell us all about serverless databases. What are they? What's the myth? Everyone does one thing, some people do another. What's it about?
So conceptually, serverless databases may seem like a bit of an oxymoron initially because serverless databases, the database typically would say it's persistent storage, some sort of data plane that has to have a form of server managing it. The conceptual difference is that when you approach a serverless database in the cloud realm, which is the realm that we've all got our heads in, it takes a bit of a different approach. What we consider is the data plane may be persistent, but the interaction points where quite a lot of the compute comes from, because no matter what plane you're looking at, whether it be the application plane, the data plane, or the control plane, there's compute involved. That's the section that kind of gets the service component. So the immediate thing that kind of comes to mind for me, firstly, DynamoDB. So you only pay for when you use it, depending on the RIs. So you've got read and write compute units that you allocate to your specific NoSQL database, and that's the key critical thing. DynamoDB is NoSQL, not SQL, so don't expect to use inner joins and left joins when speaking with it. But because of the nature of NoSQL, the serverless component of it is fantastic. You only really pay for the invocations that you run. Then the other one that comes to mind for me is something that's relatively new, and I think you and I are both excited for this. It was S3 based. It's S3 data lakes, only because S3 data lakes have now become latency sensitive to the point of, I think, close to 1 millisecond. So thankfully, due to reInvent, and for those listening, reInvent is the yearly conference that AWS runs, where they just release all the wonderful new and great things. So it comes out in reInvent, it's good and usable 9 months later for the next reInvent. But one of them was this thing called S3 Express Zones, where you can bring your blob storage, so your object storage, the latency level of about 1 millisecond or so, or let's say sub 10 milliseconds, which when you're running a lakehouse or when you're running a data lake is really worthwhile when you're talking about economies of scale. AWS takes I'd say, a bit of a perspective with their databases where they'll basically say, we're going to give you a precursor to database technology. For example, Athena, where they give you a SQL-like implementation to search a bunch of buckets, or they'll give you the ability to use crawlers and such to actually dig through Parquet files to then filter out. And that's when you start moving away from the database side and more towards the data engineering and ETL side. So I think there is definitely a world where serverless databases exist, but I tend to look at what someone says is a serverless database and then compare it to what someone calls a PaaS, so platform as a service, and where the two really fit in.
I'm a bit of a database Luddite. I come from a very old world 25 years ago where relational databases were everything. I wrote PHP applications and I did a lot of joins and everything else. And so for me, moving into the serverless database world was weird. But for somebody who still is in that world of relational databases and they can't get out of it, is there a serverless option for them?
It's serverless with these two things behind it. It's serverless in the sense of a component of it is serverless, but it's not truly serverless. So the first I'd look at is, and I'll mention there's two, but I'll stick with the first one, which is Aurora Serverless. Effectively, it gives you a nice engine that gives you serverless scalability. Now, the database itself isn't serverless. It doesn't have the performance or the makeup of DynamoDB, wherein effectively with Dynamo, you've got a secret S3 bucket somewhere very close to your compute that's actually sitting there and allowing you to process through a bunch of NoSQL statements. Instead, what serverless Aurora gives you is the ability to scale your reads and writes through a serverless nature, where effectively in the background, in a, I'd say somewhat similar fashion to Lambda, but obviously a lot slower because we're talking about databases here. As your demand increases, they'll increase the compute exponentially by having effectively in the background pre-warped instances. Now, where this is to auto-scaling groups is that serverless, you don't really have to touch. You just have to basically turn on and run with, right? Lambdas basically just give it X amount of memory and just say, for example, a concurrency limit, and away you go. That's the same approach here. So it's serverless with an abbreviation. Next would be the open source serverless component, which similar sort of scenario. You got to have hot compute. You're paying for things perpetually, so it's not serverless. So if you, the key rule I take is, if I have to pay for it like I do in EC2, it's not serverless. Simple.
Excellent takeaway there. Serverless. But no, I get what you mean there. At the end of the day, you've still got to keep that pre-warmed compute ready to do the indexing, ready to accept the queries, etc. So then how does it differentiate for the non-relational database situations? You mentioned NoSQL a minute ago. What sort of challenges has somebody got to get over on either an education perspective or a workload perspective to move from that relational to the non-relational serverless, the true serverless?
Well, I think that's more of a question of moving away from SQL to NoSQL, right? And I think conceptually, the serverless database concept is more around my interaction layer, which has always been a difficult component, which has been my read and my writes. And we can still stick in the realm of SQL here, not just NoSQL. I need the ability to scale, but not just scale through the options of waiting for a server to come up, which at that point in time, we may have hanging threads and then cause downtime and a poor customer experience. You look at how quickly can I scale my compute, where my data plane is basically just sitting there waiting to receive. The perfect example is Aurora Serverless. Aurora looks after your storage, which is what I love for it, right? I don't have to worry about it. I don't have to set auto scaling on a storage system, and it's just there. It's great. The front end side of it, I still have to have a master, and I still have to have many read instances that then I can scale the read instances with. The serverless approach with that is basically that as demand grows, it'll spin up and spin down and not worry about it, and at a much quicker rate. The downside is that it is pricier. I believe in a world where certain components from SQL were not necessary, for example, customer session data and such, they should be moved to NoSQL, where then you can take advantage of database. Now, what I mean by that is data. I'm specifically talking about things such as session state, moving, and this is where you can leverage like in other databases as well. And they're in shape and form because they are running on memory instead of actual storage. And then technically, they can be run in line with other applications. You can call them technically serverless because I'm not actually having a server, but we won't get into that point. We can really get into the weeds here. It's about segmenting out what you did traditionally in a transactional database and how that actually works with your current data stack. If it means changing a schema, it's critical, great, do it. But at the same time, you don't leverage serverless databases for the sake of just doing it. You need to find a good use case for it. One that I've seen has also been in the case of scorecards and scorekeeping. There was a metadata aggregator that we worked with for sports. And what they did particularly was they needed a way very quickly, and this is where NoSQL is great for that, where the application layer will work out statistics to give to people as they watch a sport. So whether it be, for example, we'll take basketball, or take, for example, football, as in football. We'll keep both. It's fine. How many goals has Messi scored this year at Inter Miami? Stuff like that. You use the app logic to determine, having many different NoSQL databases, each one having its own specific, for example, set of data to actually pull in and send out. Whereas with a traditional database, you've got, I'm going to make a call, I'm going to run a query, I'm going to run an inner join to create another table, and then a left join to create another table. And that is actually very compute intensive. So if you're on a legacy world, and I say legacy because, well, let's be honest, most of us are. If you're on a monolith, it might be harder for you to utilize a serverless database because it's not the technology that's the issue. It's more how your data is actually built. So I think data classification in the serverless realm really is critical. And I think that's typically something that a lot of people tend to forget about.
Yeah, and it does get a little bit confusing sometimes when people are trying to make that move over from SQL into NoSQL when they realize how reliant they are upon those joins. And some people just do them without even using the word join. But they're just like, oh, where's my this equals this? And so, yeah, they have to then step into this realm of doing it in business logic instead. What would you
Absolutely.
say?
And I think this is the main. No, go on.
No, you're good. This is the who goes first situation.
I think I was going to answer the question before it came in. Oh, I blame the 4G at the moment. Don't worry about it. It's not you and me. It's the internet. So the business logic thing is critical. Even though we are talking about serverless databases, domain-driven design will make up how your application will interact. Basically using domain-specific, the domain bounding. Effectively, we have a database and a service bound to each other, and understanding how that flow works is how you're going to determine whether or not you need to move away. The thing is, we're not going to get rid of SQL, and you shouldn't either. SQL is great. SQL, whether it be transactional SQL through MS SQL Server or Postgres or so on and so forth, it's a necessary thing to have. But you need to consider what components of it to move out. Like I said, session state, for example, you might need just aggregation of data. You might need metadata locations to be present. Like I wouldn't, if for example, you're running a serverless service, right? Say that 3 times fast. You would, and let's just say you're processing things through an S3 bucket. Well, the metadata of where that S3 bucket file is located, I dump into Dynamo. I wouldn't do it on a SQL server because it's a heavier thing to make a SQL call. And then I have to pay for a 24/7 server running, right?
Yeah, and it's always good to get rid of some of those 24/7 costs as well. It doesn't matter how many reserved instances you use, it's still nice to get it down and out of the way, so you've not got to concentrate on what's running in the background. What about things like, and in saying that, and I might be going a little bit off topic here, but what about unexpected excessive usage of something like Dynamo? Like we just saw in the news recently that Amazon have finally made it cheaper for HTTP errors on public S3 buckets, or public on S3 buckets that shouldn't have that. Is there a protection with Dynamo?
Everything is an API call. So effectively, there's 2 options that actually not 2, several options you can take with addressing your expenses with DynamoDB. Because here's the thing, S3 can get really expensive, as we saw with the errors. Lambda can get really expensive. Just ask Amazon Prime, and step functions can get expensive. So all these serverless services, and sure as heck that Dynamo can get pricey. The way approach is you got to be multi-layered, right? So when you're making decisions and picking DynamoDB choices and things like write and read compute units, and you need to consider what is my use case and how much flow will I have, right? And that's a business decision. So for example, you deterministically have tested locally, which you can, that if I have an average of X amount of users per hour, my DynamoDB database will be hit, and I'm using database loosely, will be hit X amount of times. So therefore I can choose a subsector of read and write compute units. Or you may consider that, well, do I need eventual consistency? If you do, then you can actually even adjust that further and actually adjust your indexing, where you then don't have to worry about as much for your compute side. But that's only one. This is only just taking the business approach. Secondly, you can actually apply it into how you build your infrastructure as code. So we assume serverless, we assume a little bit modern. We always have to, and my assumption is that they've done the right thing and they've gone the route of infrastructure as code. CDK, that may be a source of protectionism against poor choices. So what I've seen is with, and this is almost heresy for me to say because it's not CDK. With Terraform, people use OPA policies to check for certain specific things in their design. So they'll go basically say maximum compute units does not exceed X. So this is where you quite literally check yourself before you wreck yourself. With CDK, people do unit testing to do the same. Or they'll say basically, if look at the cloud information that's being generated, and then tell me, does the compute units and read units exceed X? If it does, do not deploy. So that's the automated aspect and then the human aspect. And then finally have alerting.
Yes.
Both billing
100%.
and the actual, what do you call DynamoDB. You have to have that. Like it's all good and great if you're having this wonderful implementation of X. But if you don't know how much you're going to spend, well, you're doing it wrong.
Going back to the well-architected framework, proactive observability. Cool.
Spot on.
Love it. So massive question here then, and this is moving away from the technical a lot of it. How can adopting serverless databases contribute to a company's overall agility and innovation strategy?
Can you repeat that last one? My internet cut out as you started the question.
That's all right. All good. How can adopting serverless databases contribute to a company's overall agility and innovation strategy?
Well, the way I look at it is that you need to find a problem to then seek a solution. You don't just go, okay, cool, we're going to go serverless for the sake of great. It's just going to be better for us. At times it won't be. Something like, say, for example, Aurora serverless, you may want to utilize like RDS proxy, and you may be just adding to a build that's not really necessary. Find a problem that you have. For example, there may be scalability with a particular component of your application, right? But it's not the compute component, it's the data component, or maybe the read component. And then see how you can re-architect that data aspect to a serverless database, whether it makes sense or not. So people have said Dynamo is fantastic for, like I said to you, like not session state, but like things that are great for metadata and such, but you may just find that serverless may not be right for you. Where I have seen it work, and this is where I'm playing two sides of the fence. Where I have seen it work and really be scalable is it provides, when you have the right bounded context within your approach to creating application layer. So say, for example, I create an API, and the singular rule of this API is to ingest values from for example, from an uploaded file and then dump the metadata aggregates to Dynamo. Well, DynamoDB, we have a clear definition of what we're trying to achieve, and we have a solution. We then also don't have to worry about things like storage. And I think that's where serverless databases are critical. It's a pain in the butt to have to receive notifications from CloudWatch through custom alarms and EC2 instances, or RDS for that matter, about you are about to run out of storage. And going back onto the traditional world a little bit, when deduplication isn't done correctly, and you've set up your own database, that will blow up your storage. If you have a massive spike of unexpected traffic, even during good times, storage has to sometimes keep up with that. Not just from a storage medium as in like raw storage you have, like say terabytes left or whatever, but IOPS as well. So this is where the unique nature of Dynamo can be exclusively better. And it's because it's taking the approach of microservices to an extent. Because DynamoDB and NoSQL databases are traditionally utilitarian to a very specific extent. When you build a service around them to basically pull X data, that's all they do. So for example, you'll have a customer NoSQL database that has a JSON object dumped into it. And that's Dynamo again. It will then serve only one purpose only. So if you're not pulling a ton of client or user information, you don't really have to worry about that component failing. Now, if we look back on a traditional database, where we're looking at more of a, say, RDS concept, we have a single connection string that's been left open, and it's running a long query. So we know that it's going to hit read, right? But it may do, because of that read, it may do table locks, and it may lock a row, or it may lock a table, and then you may be plumb out of luck because you then just going to have to queue up what you're trying to achieve. So you've got to be a little bit worried. It's finding that awkward balance.
I'm sure Bojan will be back very shortly. Airport 4G is being not his best friend right now. There he is. He's just coming back into the frame.
No. It's awkward, mate. Let's continue.
You got it? Cool. Perfect. Okay, so where were we? We were talking about the business benefits, etc.
Continue.
Not sure if Bojan can hear me. You there, mate? See, this is why I love live technology. It is always sometimes unpredictable. But ultimately, what Bojan was just mentioning there is the ability to ensure that you're balancing. Yep. Is it? Looks like we've lost him just for the moment. We can't hear you, Bojan. If you can hear us. Oh, I think he's reconnecting. But some of the things that hopefully we get to ask Bojan very shortly is how to get started, how does it connect to some of the more modern trends, and as if by magic, he appears in a third window. Okay, we have him back. Welcome back.
Cool. Yeah, alrighty. Where were we? So we're talking about what businesses can incorporate serverless databases. And hopefully my answer got carried across before it got cut away.
Yes, most of it did. Yes, you were very much spot on with the point. And I think one of my questions that was coming out of that is that most businesses have got two thoughts on the head right now. One of them is, how can I use this with machine learning? Because we've always got to plug machine learning into things. And also, how do I keep my data secure whilst doing so? So how does serverless DBs compared to, say, running my database on my tin box that's locked down, I can see my data, compared to the serverless in the cloud situation?
So there is serverless machine learning, and the idea is that you use something like technically serverless because you still have to pay for compute to an extent. And this is where we really got to be careful with where we use the word serverless. AWS gives you the ability to use things like Macy to check, for example, everything you have in S3 for PII data and very sensitive data and report it, right? And that in its own right is also a serverless service where you'll only be charged for each and every time it's invoked. Now, why do I say S3? Well, because I was mentioning before the S3 data lake setup. That in its own right is basically a bunch of storage you have, but it's only really being tracked and used for analytics and such typically when you're invoking it. Otherwise, it's just sitting there. Same with Athena. Security just comes through logic, right? Are you encrypting your storage? Are you invoking things with encryption in transit? When you are passing through data, do you understand first of all what you're passing through? So in the case of anybody who runs any sort of transactions, they have to be compliant to PCI DSS. And these compliances, although they may be painful, the reality is they have a very good use case for them, right? Which is we're making sure that when you're paying through, if someone grabs a hold of, they can't abuse. So this is where it's critical to understand that the same applied to standard databases, so applied to
I think I've still got you. Yep.
Cool.
Cool. So ultimately, when it comes to security and serverless databases, it's very important. Yes, there's certain standards that we must adhere to in terms of PCI DSS and other such standards. So how easy is it to secure these databases?
You need to look at the design. So when you're running anything in S3, how secure are your buckets and who has access to them? So the principle of least privilege, it's not just an AWS thing, it applies everywhere. I'll give you the perfect example. So we won't just look at the S3 component. We'll look at Aurora Serverless, only because it's happens to be a hot topic, right? So Aurora Serverless V2 is relatively there, but it still has components of it that don't make it truly serverless. You still need to make sure that the SQL user that you're using doesn't have arbitrary access to everything. They should only have access to the things that they require, much like an IAM role. Same thing applies for any which fashion that you give people access to the ability to scan through Athena. So if I have the ability to scan through Athena and go look through a bunch of S3 buckets and in relative terms create a data lake in some fashion by using that, I should not have the ability to view absolutely every component. And if I do, certain not white labeling, obfuscation of data should be implemented. So this is where you're going to look at your application logic, right? What I've seen a lot of the time is there's certain hashing that gets involved. So as a transaction gets processed, they'll use a encryption key, and that encryption key will hash the incoming message and then dump that into a database. And then only another service that has the ability to use that key has the ability to decrypt that database. Why that's fantastic is because you just got a 256-bit blob of XYZ that you can't really do anything with. That's secure. That's obfuscation, right? It really comes down to understanding your application structure as well. So one of the greatest things and one of the worst things that happened was that people gave us libraries to write SQL, which is to say that we're not writing SQL anymore. You'll have someone that just goes in and pulls in a library, for example, with C# for a SQL Server connection to then help them write a statement that dumps something into a database, right? It's great because it's for developers to speed things up, but the problem is you can create poorly formed table structure and poorly formed, and this is opinionated, by the way, so this is my opinion. Others may go against it, but hey, that's perfect, right? We need discourse in the community. You can create poorly formed, transactions that way. This is where you need to obviously know what you're working with. So not arbitrarily using random libraries without understanding them. Example I can give you startups. My warning immediately to every startup there is, know what you're using before you use it. Obviously you need to take risks with new technology, but every question should be, if we're going to use X, how do we make sure it's secure? That's it. Yep. We know that the library that we're using isn't secretly a crypto miner, stuff like that.
Yep. You should make sure you curate your libraries and make sure you know what exactly what you're using. Yeah, that's exactly. And then get everyone using the same thing if you've got multiple developers. So let's make this. We've tapped your brain pretty hard. We've gone pretty deep on a few topics there. Some you probably weren't expecting. So let's just take a step back. Let's come back to the level 100. How can we get started? If somebody's out there going, I've been wanting to do this, but it's I don't know where to start. What do you recommend?
First of all, look up what NoSQL is. And the reason I say that is most serverless databases are NoSQL, at least in the sense that they're truly serverless, like Dynamo. And then jump onto the AWS console and head straight to DynamoDB. The wonderful thing with AWS is that it has many consoles for many different services, right? And the wonderful thing is that you can make and run queries in your DynamoDB table that you can create from the console, from within that very same console. So if, for example, you've created what you think is the right structure for a basic NoSQL database, you can then run a test query against it to see if it's going to work. And then you can see, okay, great, I've seen that it works. I've set my right compute units. Then you can take what you created there, that message for you, right? And then start looking into the DynamoDB SDK and seeing how to use that. So let's just say you come from the world of Python. There's a Python SDK for you. There's a JavaScript SDK for you. If you're in Java, God help you. Nonetheless, there is a Java SDK that you can use. And there's plenty of others. So you can look at it from a hands-on perspective straight away, which is jumping onto the DynamoDB console, jumping into the documentation, understanding it that way. And then there's the more pragmatic developer way, which is once you've clicked ops that, see what you can do with code.
Awesome. Cool. And what about community resources? If they get stuck, like at the moment we are talking to, the LinkedIn communities, the YouTube communities, but somebody who isn't involved as say you, me, or somebody who doesn't work for a consulting company, what sort of resources can they exploit inside of the community?
Well, let me throw a couple of people at you straight away. One is an individual called Wendy Wong. She is a AWS data hero. In the past, she actually worked at the same company I have under Liza, which is AI and ML group, and she's incredible. Her content, first of all, is both level 100 up to level 400. I believe she has a master's in data science as well. You'll find that her approaches to serverless databases and data inside of AWS in general as I think a really interesting point, because it isn't just about here's this technical service and explanation of it. It's quite involved. So really jump on her LinkedIn and have a search through the blogs, because there's a ton of content there. Otherwise, attend your local meetup. So for example, in Sydney, we have a data engineering Bites, which is a conference that happens every so often, run by the wonderful Peter H. And great if you want to attend. If you want to attend a free one, the data engineering meetups globally and Australia and New Zealand fill that gap nicely. You'll find a ton of user groups across various different clouds that basically provide you every resource you could potentially want.
And if you do want to get involved in your local user group, I've just put the link on the screen. Make sure have a quick look for your local meetup. And honestly, these are global. These aren't just like Australia or America. So you can find your local meetup either, especially when we're looking for data groups as well. There is data groups in Australia, America. They are very much tuned to local specialist groups as well as generic groups as well. So as you can see on the screen, the Sydney Serverless Meetup, there is also the Melbourne Data Engineering Meetup as well. So there you go, quick plug for you.
Love to see it.
Excellent. Well, I think that's about all we've got time for today, Bojan, but I really appreciate you coming on board and helping us out, talk about serverless databases. The one last thing that I am going to quickly plug, because this is an absolutely amazing thing to get involved in. Serverless Days ANZ, that is next week, I believe.
Oh, yeah. So let me give you my 2 cents on it. Serverless Days ANZ is the place in Australia, especially if you're in Sydney, to go to see not just myself speak. I'm going to give you my own shameless plug there, or see me at a booth. But it's to see a global community of serverless enthusiasts coming together to present on either their war stories or what's happening new, how they've actually come across in serverless, and basically a bunch of storytelling that typically you can't find from Googling and YouTubing. It's a one-off event that honestly, it's like no other. Whether you're across Azure, AWS, and in some cases GCP, you'll find a talk for you, and in some cases even AI. But the wonderful part is this isn't just the big 3 clouds. We've got people coming to this event who are also third party, who are independents, who've created their own serverless infrastructure as code. And really, you can take advantage of that by having a condensed day that will give you months worth of knowledge. And really is nothing else like it. I'm so happy that's finally come to Sydney as well.
I was looking forward to it. I can't make it next week, but I really hope anyone that attends it has a great time and gets a lot out of it. And I'm looking forward to maybe some of the online recordings later.
Absolutely. Mate, you break my heart. I wish you were there. You'll be there in spirit.
I'll be there in spirit always. Not a problem. Cool. Okay. Well, thank you, Bojan, very much for spending your time with me from the airport. I appreciate you just got back from Melbourne and you are literally on the way home to your wife to then go on your honeymoon. So I really appreciate you taking the time out to be with the sounding board today. Enjoy your evening, safe journey, and I'll catch you on the flip side.
Thanks, Alan. And just quickly before we leave, mate, it's an absolute pleasure. I love what you're doing with it. And the sounding board has been a fantastic approach to the community, and I can't wait to see more.
I'm having a lot of fun with it. I get to work with people like you, and it takes me back to my roots as well a little bit. You know, we all had to start somewhere, and this is what this is about.
Exactly.
No worries. Thank you, Bojan. Appreciate it. Don't forget, guys, if you want to get involved in the sounding board, you either want to suggest a topic or you want to come on, just like Bojan did, and be a community expert, then over here, I got it right this time, there is the little QR code to scan. There's a form there that you can fill out, and we'll then receive that, and we'll consider it, and we'll let you know what we're going to be doing with it. Also, if you do get stuck with a problem, don't forget, ask your rubber duck first. Good night, guys. Take care, and we'll see you next week.